Here are 5 cool projects that you can build with the Raspberry Pi Pico board and just 8 LEDs. You can use any other board for these projects as long as it has 8 GPIO pins with PWM support. We'll be using PWM exclusively to create these cool patterns. Each project comes with a challenge to test your understanding. Try to solve them all and drop a comment if you need help. First, let's connect 8 LEDs to the GPIO pins 6 through 13. Make sure to connect a resistor in series with each LED to prevent damage. We'll write our code in MicroPython and use the Thonny editor to connect to the Pico board and run it. For our first project, we'll create an ECG wave using the 8 LEDs. As the human heart beats, it generates electrical signals that can be measured using an electrocardiogram or ECG, displaying a distinct wave pattern that doctors analyze to assess heart health. A typical ECG wave has 5 main segments labeled P, Q, R, S, and T. First, let's create PWM objects for each of the 8 LEDs and write a function to adjust the brightness of all the LEDs based on a list of brightness values. To simulate the QRS complex, we light up all 8 LEDs quickly. Then we create a small pause for the ST segment, which lasts 0.5 seconds. Next comes the T wave, where we light only 5 LEDs at 60% brightness to show a smaller peak. Finally, there's a longer rest period corresponding to the RR interval that lasts 0.6 seconds before the next heartbeat begins. Now, a challenge for you: irregular heart rhythms can be a serious health concern. Take a look at the following abnormal ECG patterns and try to simulate them using our setup. Watching waves on the beach can be very relaxing. Let's recreate that peaceful feeling with some LEDs. We generate smooth Gaussian waves that flow across the 8 LEDs, alternating between large waves at 80 to 100% brightness and smaller ripples at 30 to 50% brightness. Each wave consists of a main peak followed by a smaller secondary peak, creating a natural-looking pattern. As waves move from left to right across the LEDs, the program carefully calculates the brightness of each light to create smooth transitions. Just like real waves reflecting off the shore, our larger or faster waves bounce back when they reach the end, though with reduced brightness and speed, while smaller waves gently fade away. The timing between waves varies randomly, making the pattern feel organic and unpredictable, just like watching real waves on the beach. Now for our challenge. We can create wave-like patterns using functions besides the Gaussian. Here is a list of other mathematical expressions that can be used to create waves. Find out which one is most realistic. Coherent breathing has been shown to have many health benefits. So for our next project, we'll create an LED breathing guide. We start with our usual setup of configuring the 8 pins for PWM. The main function of our code takes for parameters: inhale time of 2 seconds, hold time of 4 seconds, exhale time of 2 seconds, and rest time of 1 second. During inhale, LEDs light up one by one from bottom to top over 2 seconds, creating a rising effect. At the top, the highest LED gently pulses for 4 seconds to indicate the hold phase. The exhale works in a similar manner. The code uses PWM to create smooth brightness transitions, making the animation look natural and calming. For this challenge, connect a speaker to the board and use it to guide the listener through different breathing patterns. Campfires are truly mesmerizing. Let's capture that magic in our next project. Just like a real campfire grows from a small flame to a full blaze, our LEDs light up gradually for a realistic effect. We start with the ignition phase. For 3 seconds, only the center LEDs light up, followed by the spread phase where the fire gradually spreads to the outer LEDs, mimicking how real flames grow and spread outward. Finally, we enter the continuous burning phase where all LEDs stay active, with their brightness constantly changing using random values. The middle LEDs burn brighter than the outer ones, just like a real campfire's core burns hotter than its edges. For this challenge, Try adding a random velocity vector to influence how the campfire flickers and behaves. Finally, let's simulate a Geiger counter. A Geiger counter is a device that detects radiation. You've probably seen them in movies, making clicking sounds near radioactive materials. The animation simulates a radioactive source getting closer over time. Our code uses the inverse square law, where the intensity of the radiation gets stronger as we move towards the source. Starting from dim and occasional, the flashes get more frequent and intense as time passes. Each flash triggers multiple LEDs randomly, creating that characteristic Geiger counter scatter effect. The closer our virtual radiation source gets, the more chaotic and intense the flashing becomes. For our final challenge, attach an ultrasonic sensor and a speaker to the Pico board and modify the code to behave like a real Geiger sensor. We hope that you enjoyed the projects. Please like and subscribe our channel and drop a comment if you need help.